We're almost done with this chapter, right? So I think, we can
No,
kind of.
actually, I wouldn't call we are done because there are some stuff that we didn't cover properly.
Mhm.
Um, Actually, I would prefer we finish it off with the REST and R. I think we spoke a little bit about REST and RPC, but we didn't kind of touch upon all the points the author is mentioning.
Mhm.
Especially towards the end, he talks about actor model. Are you familiar with it? I'm not aware of anything. This is a maybe we can just find some look up some links some online and kind of read up. I was trying to understand, I was trying to go through some YouTube links to understand what it means, but I didn't still get it completely. But yeah, let's go over stuff again, like data flow through services. I mean, so we don't gloss over details.
I'm fine with that. I read the whole thing, like this
Yeah.
past week, and I got through the entire thing. So, um, you
Yeah.
know, I think we can just kind of um go through, all of the points once more if we want.
Yeah.
Honestly, though, like I kind of agree with Karthik in that we shouldn't get buried in details. Um, because the issue is that like ultimately, you probably will still only retain 20% of what you read in this book. You have to use a lot of the technologies here. You have to make it practical. Um,
Yeah, but can you gloss over stuff? Are you in a state, in a place where you can look at this section and kind of summarize where it is appropriate to use REST and where it is appropriate to use RPC? I mean, at least that high level understanding, that distinction you should be able to make, right? You don't have to kind of implementation details. I agree, don't have to worry about, but
mhm.
where does it make sense to use REST? And where does it make sense? So, for example, towards the end, right, the message broker model, message passing through using message brokers, like that's where Kafka, we could have a discussion on how Kafka SQS work. So I have experience with SQS, so I can speak about it, but I have not used any other messaging systems, the RabbitMQ active, so that I don't understand. But yeah, I think the overall idea might be the same. Maybe the implementations are different with RabbitMQ, all those things, but it's still worthwhile to understand where it makes sense to use those versus REST and RPC, because at the end of the day, they are just basically somebody is asking another process to do something, and whether you get the response immediately or do you get it asynchronously, and what are the advantages of asynchronous processing. So I think that's a good discussion to have.
Okay, yeah, for sure. I agree with you on all points. I think we should probably just kind of, um, get through, these sections here, and then, go over, uh, some of the things like the actor model, because I remember reading about it too, and then maybe sort of the schemas, going back and just seeing like, do we understand, why we have a schema or what the schema represents, and also like areas where you don't need schemas, um, and then future and backwards compatibility. Those are things that I want to review as well. Like you said, REST and RPC. Um, okay, so let's go ahead. I think we got some of the others here, so we'll go ahead and start. I think last time we started or stopped around like the Avro chapter, I want to say. Um, what
we
all do you remember where we stopped?
we stopped at RPC. So
RPC? Okay.
right. No,
So,
actually, did we talk about WSDL and So basically with the REST, right, you have two ways of doing it. Yeah, basically the web services. So web services, there are two ways of doing the web services. The REST based one, which is more open ended, and there is no basically it's simpler, less strict. But like the other approach is to have the SOAP SOAP based for the basically the SOAP based network API request, right? So basically you define the request format using WSDL files. So it is a kind of the files work as in the documentation. Correct me, Karthik, if I'm wrong. So this is basically WSDL is like an it's the intention is for the consumers of the service to understand the API, to see what is what parameters and what is the response formats. Is that the intention of WSDL? I have not.
Yeah, kind of. Amelia, like results are, think of like it's like a contract, right? Basic contract of your web service, which defines your payload, input payload, output payload, and then pretty much it explains the type of the payload itself, right? Like the payload might not just have simple primitives; it might sometimes have custom objects that's defined. And how the whole payload is structured, right? Like, okay, this element is like, 0 to multiple times. It's kind of like a list object and stuff like that. So it defines the whole contract of your payload object and the type and all the elements in it, whether it's optional, mandatory. Generally, it's accompanied, generally WSDLs are handed over. How these objects are built are using XSD schemas. So they go together hand in hand, like WSDLs and schemas goes together.
Yeah, typically I think if you use those WSDL, the frameworks which given a WSDL, they basically give you auto-generated those classes, basically the request response classes that you can just directly set, and they take care of actually serializing and deserializing basically the contents of the request and responses. So I think that's all there is here.
Yeah, in that world, it's referred. It's funny. It's actually serialization, deserialization, but in the WSDL world, it's just referred as marshalling, unmarshalling of the objects. Basically, it's like Java object to an XML kind of a schema conversion, right? And unmarshalling is schema conversion to Java kind of object.
Mm-hmm. Yeah. So that's what they say. Basically, he's saying this definition is useful if you're using statically typed languages like Java, C++, where these are, the code is generated for you, the request response classes are generated for you. But if you're using a dynamically typed language like Ruby or Python, it's not super helpful that you have a WSDL ahead of time. And yeah, the one that you highlighted, right? RESTful APIs tend to favor simpler approaches, typically involving less code generation and automated tooling. Yeah, so basically in our project we use API gateway. So in API gateway, you define your REST endpoints. So the language we use for defining the request response formats is using Swagger files. So let's say, right, it's an open API specification that basically lets you define what are the required parameters, whether this is a query parameter or should it go in the body or like, stuff like that. So that's a specification that we follow as well. Yeah, next is RPCs. Anything anybody has to add? Okay. Yeah. So RPC, I think, again, so RPC, I think it is evolved as a extension of calling a method called locally. So they wanted, the original intent was to abstract the idea that this call is going over the network, and a call to a like, how would you just make a call right to a file, right? It's a local thing, and it doesn't, I mean, the caller should not worry about whether the call, whether the, you know, the write is happening locally to a file or over the network. So so I think that the RPC idea for RPC came with that. But like the author, he says, yeah, the location, it's called location transparency. Yeah, the RPC model tries to make a request to a remote network service, basically to act the same as calling a function or method in your programming language within the same process. Yeah. But yeah, he says that it's not, I mean, although the idea is that it's a fundamentally flawed approach, because there are lots of things that could go wrong on a network request, right? Like the call might just fail and you don't know the cause for failure. And that usually there are no logs because it happened because the remote service completely, you know, died. So there are no logs to look at, and just timeout might have happened. So in order to kind of bubble up those exceptions in a location transparent way is not gonna work. You have to handle those in a different way, because like if a local, if you did not if you could not write to a file right locally, either because you don't have permissions or something like that, you would know what happened. But if it was a network call and you got a 5xx or something, so there is a hope of, you should, the right approach there is to retry, because like 5xx and those errors tend to recover when the service is up. So you have to follow a fundamentally different approach to remote procedural calls. Yeah, I think we can just read through this, I guess. A local, you wanna, yeah, a local function call is predictable. Yeah, you are on, yeah, if you retry a failed network request, it could happen that the previous request actually got through and only the response was lost. Yeah, so that could also happen, right? Like you just didn't get the response, but what you intended to do happened. So that does not happen on a local call. So you have to put effort to develop RPC based APIs to be idempotent because of the network element, because things get retried and it should not leave the system in an inconsistent state. And every time you call a local function, it normally takes about the same time to execute. A network request is much slower. And yeah, actually the content in the book, in the hard copy, and this is actually different. So maybe I should just look at the screen.
Oh, really? Okay.
Yeah. Yeah.
Well, I mean, like, I didn't mean to highlight everything here, but I just kind of started going down it, and then I was like, okay, I guess these are all bullet points about RPC versus REST, where RPC, you have to, you know, think about things like network failure, which is what this guy is talking about, essentially, when it comes to working with the internet. I mean, if you just use functions locally in your program, you don't have to worry about any of these things. But network requests fail, and so you have to kind of design for that, including like duplication, but you have to make sure that you're not like repeating the same data into the database. You know, and so there were just a lot of different points here. Again, RPC tends to work better, like if you account for these things. But like it's just, again, like it's translating from one format to another format to another format to another format, right? And it ends up ugly, right? Like, because you have to eventually you have to marshal and unmarshal the data and then bring it back, ultimately back up to the original programming language. And some programming languages don't even have the same types as like if you work from one backend to another front end, with JavaScript, and then the backend's like in a different language, you can have problems with some of the unmarshalling of that data.
So that's an interesting point. So basically he's saying the client and service may be implemented in different programming language. So the RPC framework must translate data types from one language into another. So why does he say that? Because your client, and even with, I think there's a different flavor of RPC that people can implement in reality. So you could have an RPC implementation that is programming language agnostic. Like you can write your service that basically is designed around actions and not resources. I think like, for example, post add a chat message, right? Post a chat message, or archive a room conversation. So those could be yeah, I mean, they basically, that sounds like function names, right? But whether the call is a local function or it is going over the network, the client, it's not a concern of the client. So the client which is actually trying to request those things. Now, whatever the client, basically even the clients use a library of that they use to make these calls, right? So that library, I think that is the one that hides this complexity, right? I mean, at least that's how we use it in our I mean, that's how it must be done everywhere. So so I think that's,
so reality is, if you notice, right, everything is RPC. If you like it or not, even REST service underneath the hood is RPC form. So it's actually RPC. The RPC is like, think of it like a grandfather. Your service is like a father, and this is a child, right? Like, or mother, right? So the point is, REST is just the next evolution of SOAP services, right? And before that, like, if you guys are familiar with EJB, RMI, Corba, so everything is RPC. And the RPC that we talk about using protocol buffer is the next version of compressed RPC. So if you see SOAP and schema, that's why schema, if you notice everything is only defined in a primitive way. There is no list. You won't have list as a type itself in the schema. But what it will give you is, like, you can define in the schema a particular object as 0 to unbounded, which is like it's going to get repeated again and again. So that, like, any language, even Python or Ruby, any language, they can decipher this using, because every language has the primitive types: int, string, float, boolean, double, right? Like, these are the primitive things, then upon which you can truly build any custom object as well, right? So everything is RPC under the hood, just that things have got different variations and
yeah, I mean, yeah, I think I agree with you. So yeah, that's basically everything is a method call. Yeah, like that's what I was also trying to say, right? Like, basically whether it goes over the network or locally doesn't matter. But like, what I don't understand here is they say the client and server can be implemented in programming languages. So the RPC framework must translate data types from one language to another. Is he trying to, okay, so basically if you have a service that's written in JavaScript and your client is written in Java, now you, in order to expose the JavaScript, I mean the other way, sorry, the client is in JavaScript and the service.
Anyway, right, any language, a language A, you write a service and you expose it, right? You are a producer of that service, and a consumer in this case is the client, right? Think of it, any language. They should be able to decipher your whatever that service is. They should be able to form the payload so that they can, be able to meaningfully execute with the request payload to get a response payload, right? So that's why the whole language agnostic mechanism of XML came into play. right? Where XML, any language should be able to decipher it. And we managed to have only primitives in the XML, so that like, okay, they can like Visual schema and XML came into play for this simple fact, right? Because any language can be able to deserialize it and push in the data in their language format and still get the rest.
Got it. Yeah. So this, I mean, in spite of that, so basically, this RPC in this point, right, in this particular point, I think he's talking about RPC not over the network, but I think locally. Why would you want to translate the data types? Because in order to serialize, once you serialize, right, everything is it's basically programming language agnostic, right? No, actually, let me take that back.
Not necessarily. Let's say you define a class, right, in Java. Just for example, class has one of the private variables. Just say one of the collection. Let's take linked list, right? Linked list. You have linked list in your object, and you do some logic with it, right? Either add, there's some meaningful reason behind that object. Linked list doesn't exist in Python. Doesn't exist in Ruby, right? So those kinds of things will completely offset this, right? But the reason why marshalling and unmarshalling works is you define the schema. There's no way for you to define a linked list, right? Because it gets auto-generated from the schema. Your basic classes, POJOs for those objects for request and response get auto-generated from the schema itself. There's no way for you to choose a collection which is not going to be agnostic in a different language. So W3C consortium makes sure, right, like this conformity to many languages are maintained.
Yeah. But yeah, I think yeah, thanks for stopping here, Vijay. So I think
No, that was a good point. I was just going to say, like, that was actually a very good point, the way you were talking about unmarshalling towards the linked list, and how like some languages don't have that, or a certain implementation of it. So the W3C kind of works together to support all the different languages with things like XML or JSON, and then just making sure, like, I guess these types get auto-generated by the schema. That's also very important. So these are good points that you brought up, Karthik.
Yeah, I think that's it, right? Yeah, next page.
Yeah, and like I said earlier, I feel like a lot of this too, like, will sort of tie together later. Like right now, I kind of feel like it's a little tough because like we're just kind of reading it dry. But once like we have other ideas in our head, I feel like some of this will all start to click together. At least that's how it usually does for me. I mean, like a lot of times when I read like difficult subject matter, it tends to click later, rather than earlier. It just comes from just reading or seeing it more often. I think like the first time you see it, you're not really even like sure what you're reading. But then like the more you hear it or the more you see it, like you're like, okay, I think I remember what Avro is, or protocol buffers, and then definitely REST, RPC. So
right. Yeah, I think yeah, let's continue with this reading, right? So I think this is what Sadhana was asking, what is gRPC? I think here they explain gRPC is an RPC implementation using protocol buffers, which is okay. So it's basically using protocol buffers as the encoding mechanism. And yeah, has anybody worked with RPCs actually? Like, did you have experience using it in your projects?
Yeah, I've used way back in 2003 to 2007, I think. I was building as part of the product development for a BPM suite. Back then, like, I don't know if you guys are familiar with EJVs. So yeah, RPC and RMI used to be there.
Oh. But,
Yeah.
question. So can you use protocol buffers with as a payload for your REST service?
No.
Why not?
Because REST defines everything in a JSON structure. right?
No, you don't need to have, yeah, JSON. I mean, it's a header, right? In your REST call, you can set your application content to be JSON, but you can choose it to be, just a blob.
You can, but like, let's say you have the control over client and server, both implementation, both as a producer and a consumer. Yes, because it becomes too tightly coupled, right? It becomes too tightly coupled. If you have that both you're developing, it's not like being exposed outside. Yes, sure, you can do whatever you feel like, right? Only you guys will know the implementation, and like, it cannot be reusable. The whole point of a service is reusability, even though it's going to be only be used within the team. But the idea is some point maybe some other team would need it, or some other group might need it, and there is commonality which we don't have to reinvent the wheel again, right?
Hey, can I say something here? I think protocol buffers can be used with REST protobufs, and because protobufs is the way you are encoding your data, and REST is basically about how you're interacting with resources. So
Right.
you can combine them.
Yeah. So basically, to your point, Karthik, so how will the clients understand if you just send a blob? I think that's where the problem is solved with those schema writings, right? They have a schema is agreed upon, and it is also conveyed in the case of thrift and proto buffers, that schema is actually conveyed, and then for Avro, it's kind of, I mean, the schema is actually embedded inside, right? Like the offsets before the actual data tell you the data type and the number of bytes to read for this data type. So that schema is already there. So it should not be dependent. It should not be tightly coupled to the service. As long as you have a Swift interpreter on the client end, they should be able to
Yeah, I mean, you can write it, but you have to write the whole framework. You know what I mean? You cannot just shove that payload, because all our current frameworks for, let's say, JSON kind of a framework, if you choose, they gravitate towards JSON. They only understand JSON, right? Everything is built around it, right? The whole deserialization and serialization. Yes, you can tinker and make it, but nothing is available readily for you to just shove that protocol buffer into a REST service and expose it. Because the methodology is totally different. It's pretty much like SOAP, right? gRPC. So all the framework and the tooling, you have to reinvent it for you to be able to do that.
But yeah, there's nothing stopping you from doing it.
Yeah, you can build your own framework for it. Yeah, sure. Using protocol buffer, but nothing exists today.
Okay.
Conceptually, you can do anything, right? Anything can be done with anything, but there is a reason why these things are defined a certain way over the other. You know what I mean?
Yeah. I in my project, I think they use proto buffers over WebSockets, not using REST endpoints, but yeah, using WebSockets. So yeah.
So I think like towards the end of this chapter, we should just probably have like a cheat sheet for terms, just so we kind of remember like at a high level, like what all these different things are, right? And why we need them. Just kind of like, why would you build a RPC on top of a REST client, right? Like there may be a reason for that. Like what is the issue with REST that makes people want to build RPCs on top of REST, right? Like those are things that we should probably definitely know. Is it about structure? Is it about trying to make sure you get the right or the most condensed, payloads that, are encoded that can travel over the network? Are you trying to build for like network safety? Are you just trying to like make sure that like your code is preserved in the same exact type that you sent it from over to the client? It consumes it in the same exact right type, all of that stuff. These are things that I think all matter for this chapter.
to the point that people build RPC libraries on top of REST, that is interesting. I think the reasoning being since REST, the tooling around REST is huge, right? Like all HTTP call, I think the protocol itself is written for REST, right? Like get it's written to use get and then post, all those CRUD operations. RPC, when you are implementing an RPC using, if you have to communicate over HTTP, right now you're stuck with those words, the get, post, and all. So you have to kind of make it. I think that's the reason they have to use REST is because of if they have to use over HTTP. I think that's probably the reason why they want to make their REST RPC library. No, it's actually what they're saying is they want to build RPC libraries on top of REST. Yeah, I think again, so basically, if you want to use HTTP, right, you have to use the REST and then make it comply to your RPC library API definition. I was going through this YouTube link on how RPC Slack as an example, right? I have that in the Notion talk also. So they have this RPC, they call it an RPC API. So it looks like if you look at it, you say get post, get room messages. I mean, yeah, that I think is how REST also looks. Can we bring that up? The designing, yeah, I think they have examples like
Where do you want me to go?
the
Just real quick.
Notion link.
Oh, okay, sure.
I think it's the 4th tab.
4th tab. Thank you.
Yeah. So if you scroll down, they have an example of how RPC how an RPC API would look if you kind of did it over HTTP. So yeah, chat.post message. So chat.archive message. Basically, you don't have an archive as a verb in REST, right? So that's why it's not Slack has chosen to use the RPC schema because they want to have more operations than what REST offers out of box. So
I think so. Maybe we are a bit confusing here. Today, JSON doesn't define any conformity, right? You can write whatever you feel like. Your request payload, response payload, right? There is no validation, conformity, and stuff. But if you want to expose your service with conformity, right? Let's say there are multiple elements based on some element 2 comes into the payload and element 6 should be there, become mandatory and optional. So a lot of combination. You can use any kind of a language. It's not just a protocol buffer to define that schema. There are some schema, JSON conformity tools too. JSON schema is there, right? There is something called JSON schema. So, or RAML, a lot of toolings are around, but there is no standard ways to do it. Everybody does it differently. So you can use your protocol buffer to define that schema like we spoke about in SOAP, like a IDL. It's called integration definition language. So you can define that, and then from that you can take and define your JSON structure. But it doesn't give you the benefit of protocol buffer if you don't generate everything in a binary compact form, right? You can just use it for kind of a payload, kind of a conformity, both upstream and downstream, request and response, if you will. But it doesn't bring any benefit of protocol buffer. So what I was talking to you before was like writing tooling to be able to support that, be able to generate that compaction in a binary format, right? Serialize in a binary format to be sent over REST. For that, we need to completely rewrite things and add things, if I was not clear.
Yeah. So yeah, basically the reason I had come to this Notion link, that was basically the previous point to that. Yeah, if you use anything that is non-standard, right, like you have to write tooling yourself. So yeah, I get that. So basically here, what I was trying to tell was in this book, right, they say people build RPCs on top of REST. Now, why would you do that? Just thinking aloud, I think it is because if you want to communicate over HTTP and you have to, is there a way to communicate over HTTP other than REST? I have always used REST with HTTP, so I don't know if
SOAP is over HTTP too. Everything is over HTTP, right?
okay.
Technically, if you see, yeah.
Okay, SOAP is over HTTP. So how do so this get and how does SOAP API look like? Can we just take a look quickly? Because it the REST, right, you have this verb and then there's a resource, and how does that translate for SOAP?
So there is no concept of verb and all. In a SOAP, you'll have a URL, you'll have a WSDL, right? And then everything communication happens over TCP because it's a SOAP protocol over HTTP. And you have a SOAP header. The format of the whole compaction, it's not like as compacted like binary. Like you'll have a SOAP header, you'll have a SOAP body, and a SOAP envelope, right? This is a structure of SOAP itself, defined by W3 consortium. Unlike REST, which completely is over HTTP, right? SOAP protocol works on HTTP, but it has its own, format goes under it. Under JSON, there is no such thing. It piggybacks on the HTTP completely, right? Your HTTP codes, your HTTP envelope, HTTP headers, and it doesn't define its own JSON headers and stuff like that, right? The whole payload just goes over HTTP, just like any communication that happens when you go to the website on TCP.
Does SOAP work over HTTPS?
Yeah, it does. Yeah,
It does.
yeah, it works both. When I say HTTP, assume it's also HTTPS. So basically, SOAP, JSON, everything works at L7 layer, right? In the OSI model, right? Capable of session, all those things.
So, interesting question. So, HTTPS is just encryption and decryption at the end, right? The actual, basically, that's you kind of encrypt it over the wire,
right?
Kind of decrypt at the client, at whatever the receiver. So,
yeah,
not
that's right.
Yeah. Okay. So, yeah. Okay. This is interesting. So basically, is SOAP still used? Should we bother learning this? I have not used this, but yeah.
I mean, some legacy people, they still run.
Yeah,
SOAP.
if you use some services, like I remember a couple of years ago, I was working with UPS, and I kept asking, "Do you have APIs?" And they said, "No, we use SOAP." And so I had to kind of go and learn what SOAP was at that time, and then just like Karthik is saying, right? Like I had to learn about like these envelopes and being able to send a request using a SOAP, SOAP creating language, like with some library. I mean, like not language, but just like passing it on the server side and then waiting to get back like a SOAP envelope with the XML payload and all that. So it was little different from JSON, because JSON is like right in your face. Like you can just make a simple call, with like simple libraries like fetch or whatever, and you get back like JSON immediately and you can start processing. This requires like some more overhead in some ways, a little bit more complicated.
So to make a SOAP call, like for example, if to test a REST API, right, you could just bring up a Postman client and you can just write up your own request. So for SOAP, if you have a WSDL file, what do we do with it? Like, how do I make a SOAP call if I just want to test an API without actually writing an entire code?
So, do you know? Have you seen a product called SOAP UI? It's open source, like Postman. When you import a WSDL, it'll create the payload for you, request payload by default based on whatever conformity is there. Like mandatory elements, it'll automatically populate, and it'll give you the request hub. And then you can just write whatever based on whether it's an integer, string, whatever you want to send. Like you can fill in those details and send it, pretty much like Postman, right? There are tools.
Yeah.
Here's kind of like a basic like kind of project you can do if you want. This is using Java Spring, and it'll show you like how you create like the SOAP request. So like
Yeah.
these are kind of like the things you have to do. You have to create up, like all of your endpoints and REST points, services. It's like a little bit more complicated. Then you have to import, I guess schemas. It's a little bit more complicated than doing like a simple fetch request, right? Like once you have all this together, then like you can basically test an application here and then make a SOAP request.
So
And
is there any advantage to using it? Is there any place where you would want to use SOAP over REST?
I know one. So SOAP has more stringent security features as compared to REST. I read about it yesterday only.
Security wise, yeah,
Yeah.
because it is hard to use.
yeah, that's right.
Okay.
No, I mean, like we have to just kind of, digest some of these benefits ourselves. I mean, I remember like looking at WSDL files again, like with UPS. Let me see here, UPS with XML. Yeah, so I think it's still the same.
Yeah, let me come. If there is
This is what I remember getting from them, like too, because I like emailed them when I was working at a moving company, and we were trying to get like all the zip codes in the US, and they had some kind of service for doing that. It was like zip codes and cities and things like that. And they gave me this, and I was just like, what is this? And I had to sit there and read, like, and I still didn't really understand it until like I asked another person I was working with what this was. And so then we're able to kind of figure it out. But yeah, UPS uses it. So
yeah. Okay. Yeah. If there is
okay.
benefit to using it, then maybe it's but if it is more secure, like if it makes it less accessible for hackers who are trying to bring down your server, then I would think that is worthwhile to consider. Because REST is so simple, people just come up with URL paths, random URL paths, and they just make a GET request. Like we get a lot of those things.
Mhm.
People just like randomly generate. So they come up with they discover your base URL, whatever the service URL, and then they
Oh
just
yeah.
with get calls, append random strings, -u /user /business, some stuff. We just get those. So yeah, if SOAP is going to protect us with that, from such nonsense traffic, then.
Well, I mean, in REST too, you need a token now to be able to make any kind of request. Otherwise, like it'll just exit the function, which is a pretty good solution.
Right, even that, you have to do some, you have to have a server thread which actually validates if there's a token or not, right?
Right.
Some of them don't get past that, but even those, we see such huge amount of traffic, which is just gets rejected by the token validator. But yeah, we still get those invalid requests quite a bit. So it's a hassle for us, for the on-call, to kind of keep them under control. Okay, good discussion. Okay.
Hey, I have one question. So between RPC and REST, which is faster and why?
I think RPC is faster. RPC, when I'm I think the way I'm imagining RPC is the way I have read in that, I put it in that design, in that like in the Notion link, right? It is essentially a REST call. It's just following RPC ideology, which is basically so yeah, first for example, right, it is, but the reason I say it is faster is, if you if you have to update something, right, how do you update it? You have to make a post call, or a patch call. So, or a put, post, and patch are the update verbs, right? So if you have to use put is you have to basically, if you are trying to update a single attribute, you have to send the entire payload. If you had a RPC update name, right, then you just send that name, send the name and the user ID, and that's it. You don't have to send the entire attribute. I mean, if you are strictly following the REST, you know, REST way of doing things. REST is more, I think it was written in a generic way so that people can easily consume it. So it has to follow certain standards. With RPC, it's more loosely defined. You can define your own method. You can say update name. You can have a update name, update salary, all those. Each one could be an endpoint. So the payloads will be smaller, but you could have an explosion of URLs.
Yeah, that makes sense. Yeah, definitely. I'd like to see, maybe at some point, right, what people actually say about REST versus RPC. But I think you hit the nail on the head with like less, less stuff you have to send over, essentially, right? With the RPC, like you can kind of have simpler functions and they can do simpler things. And so I think that's sort of the point of like why, actually that might be why like people want to build RPCs on top of REST, right? Because they're still trying to get past like the whole like, oh, I need to keep everything in this giant JSON tree and I don't really need everything. I want to like move towards something that's a little bit simpler. So, all right, let's see here.
From a performance standpoint, the other benefits RPC brings is like you define your schema, right? So your schema conformity, validation, everything can be offset right there rather than actually going to the hitting your service itself. Let's say if your payload is completely wrong. Today in a JSON, there's no way we eliminate that before it hits the actual implementation. We go check at the implementation, see, oh, this particular field is not available. You try to unmarshal or deserialize the JSON request, and then you find that, right? But in SOAP or even any RPC kind, like, it's built into the framework, it'll just reject it right away. So that's additional benefit too, right? In RPC style.
Karthik, isn't RPC and SOAP completely different stuff, right? Like you get that benefit with SOAP because
so think of even in the protocol buffer, you define a proto, right? That IDL file. Mm-hmm. It brings that capability. That's what I said. Think of gRPC as the next version of SOAP or RPC, a more optimized version of that. Right? It has the same principles, underlying principles, and the bells and whistles around it. Pretty much, it has the same thing, right? But it's better, right? Back in days, Intel Pentium 2 versus what it is now, right? It's something like that. Not so much of a gap, but I'm just saying it's a better version of SOAP, better version of RMI, better version of RPC, right? More optimized as years go by.
More optimized way of sending the payload, right? RPC is the way you kind of decide to make the call. Is the way.
Correct. That's a call. Yeah. I'm just saying gRPC, the whole point was it also does that, the way of call, and also it has capability, how it compresses over how SOAP was. So SOAP versus this is much more optimized.
Yeah, I understand protocol buffers and SOAP are kind of analogous in the sense that schema is enforced, and if there is a schema invalidation, if your payload is invalid, it's likely that it is caught at the time of the request being sent instead of on the server side. That I get. But yeah, I think the fundamental idea of RPC is kind of orthogonal to what encoding you use. Encoding, or like what is the payload structure?
So also another thing that we kind of get to in this chapter here is that it says that custom RPC protocols can achieve better performance than something generic like JSON or REST. But REST is really good for experimentation and debugging. And so I think that's why people start off with a RESTful API in the first place. It's just simpler to use. There's not a lot of setup required. And you can just kind of start testing right away.
In the previous chapter, in the previous page, right, they say RPC is like, if you are programming, then I think the concept that you will probably use in the programming languages like JavaScript is a future promise, the concept of promise, right? I think that is close. That is how an RPC implementation would look like, where it is a method call, but internally it is actually making a network call and kind of returning the response to you asynchronously.
Yeah, and this part here was just kind of, I think they were trying to, like encapsulate, like he says here, just again, like that whole idea about like functions from the previous page where, if you can put everything into a function, okay, this function does this specific task, right? Like, sum 2 and 2, and then the next function, transmits this over to a network. Then the next function goes back to the database and then writes, 2 and 2. So like, if you have like these 3 function points or like, these series of functions, you can kind of see, okay, where is the fail point? Because if something fails, then you can get like a better answer as to why it failed. And, it's not like part 1 or part 3, it's somewhere in part 2. So, and then you also, I guess like he says here that it simplifies situations where you have to do things in parallel, multiple services in parallel, and you can combine their results. So you can kind of like combine. And again, like that kind of goes back to that Netflix like example that I was seeing before, the gateway pattern, where like you kind of like get a whole bunch of requests and you simplify them into a single request, and then you make a simplified response as well. Like like you have a response that gets built up from various services altogether. So I think that's kind of like one benefit of like working this way, like at least in this functional manner.
Yeah, this is the first line. Yeah, custom RPC protocols with the binary encoding format can achieve better performance than something generic like JSON over REST. I think that's what Karthik was saying. Yeah.
So and then there's a lot of tools available for anybody who wants to use REST. So this is the main reason people use REST. So I guess like, let's see here. We got like a few more minutes, but we did kind of touch on a lot of the different points here.
I think that you should underline, the thing that you underline, right, is a main takeaway. Where would you want to use RPC? Where would you want to use REST? If you are trying to be a public service where you want the clients to consume your API, then REST is the way to go. But if you are doing inter-service communication and if you're doing it within same organization and you have control over who is going to consume it, then you can just play with an RPC with the binary encoding format of your choice and optimize it to the core.
Correct. Yeah. Okay, let's see here. I guess we got 2 minutes here. Do we want to kind of just like talk about sort of like next steps? Because I think this chapter ends pretty soon. It does get into the actor model programming that you were talking about at the beginning.
I can just quickly talk about the
let's talk about this.
Synchronous stepping, right? No, not the actor model, the previous
okay.
Message passing data flow, right? So there is another model where so far we talked about RPC and REST, which are basically synchronous way of communicating, and the other other implementation, other way to basically there's another asynchronous way of communicating between the producer and a consumer kind of basically setup. So where you have this is, I think this is in more this is in line with event-driven architecture kind of scenario, where the producer that is not expecting anything from the subscriber. It's just basically emitting events, and subscribers are actually, there could be multiple subscribers. In case of REST and RPC, right, there's usually one client and one server. But with the asynchronous, this event-driven architecture, you have multiple subscribers, and there is no waiting. I mean, the client is not like this. In the case of REST and RPC, the client is expecting a response, and it's kind of synchronously blocking on the response, right? But in this message passing data flow kind of paradigm, there's no waiting. Basically, the publisher just emits an event and forgets about it, and then it's the subscribers which they deal with what to do with that event. So there are multiple advantages with this, in the sense that it's not now the producer and subscriber are kind of decoupled. The availability of each does not matter to the other one. And if the subscriber is down, right, so the messages are there in the broker to in the message in the message broker to basically revisit and re-deliver those messages to the subscriber when it comes back up. And now the sender, also the sender does not need to know the IP addresses or the port numbers of the subscribers. All it's only dealing with the message broker. I think that's one paradigm of designing things. And there are many examples of message brokers. Amazon has SQS. I think there is Kafka, which is open source, and another implementations, RabbitMQ, ActiveMQ, all that. So the idea is simple. There's a topic that you create a topic, and something called a topic is essentially is the message, is a kind of a buffer. It's a queue, right? Topic is a queue of where you can park your messages, and a publisher writes to this queue, and subscribers consume the queues, consume the messages in the queue. So there are some, you can define how this message can be redriven. Like, let's say a subscriber is down. First step, you can define when the message should be deleted from the queue. Should the message be deleted after successfully delivering to all subscribers? So what happens if one of the subscriber throws an error? How long should the message be persisted in the queue? So all those are configuration options that you'll have on the queue. So I think I don't have any experience using Kafka. I know Akanksha has some experience using Kafka, but I think, I mean, reliability and configurable. I mean, we use SQS quite extensively in Amazon. And I mean, I think SQS we never felt that, this feature is lacking in SQS. It kind of gives you many features that you would want in a message broker out of the box. What I've heard, Kafka is much more faster, and
Kafka has a high throughput.
Yeah. Throughput in the sense, it can take in large amounts of event payloads and kind of reliably deliver. SQS also does that, but SQS has something called delayed message sending. So you can send a message and then time it, like send it after 10 seconds or whatever. And if you can even say, if the worker is if yeah, if you can basically time it so that you don't, if there is huge amount of traffic, right, you don't kind of flood the subscribers all at once. You can delay time it. I don't know what this actor model is. I wanted to read up. Looks like it's an alternative to using threads. It's a programming model for concurrency in a single process. Yeah, I have to read up about it. Okay, so I think I will read up. I'll understand what that means, and then I can talk to you next. Actually, next class, yeah, we are over time, right? So next class, I'm kind of traveling, so I might not join. I will not be able to join Friday class. So you guys can start the next chapter. I will read up and talk about actor model, the class on Wednesday.
Okay. All right, yeah, and we can kind of finish up this part. Because we're basically at the end of the chapter, and then after this chapter, everything sort of becomes a little bit different. We start talking about
Hey,
distributed data.
next class, can we discuss whatever we have done in this chapter? There are a lot of terms we discussed, and going a brief overview of each of these, when to use what, and the
Sure.
advantages, like having a brief snapshot and taking notes about, like having notes about them, I think is essential in during interview time. So
Yeah.
Sure. I think, like I said before, maybe just having some kind of cheat sheet that will be like very helpful. I can start working on that
okay,
this week after vacation, all that, like
Friday I'm leaving for India, so I'm not sure I'll join. I'll try to join, but
Yeah, Friday I will not be able to join too. So yeah, I think if one of you are joining, then you probably can kind of just go over and update the notes in the class.
yeah, that's fine. Or if a majority of us are not here on Friday, then we can just agree to like meet next week and then just work this week kind of on just notes. And I think like all of us can just read over the notes we have again, and then try to update that as well. That could work.
Yeah, that's okay with me too. Yeah.
Okay, so let's do that then. We'll call Friday off, and then we'll just work on our notes, and then we'll review all of this next week. But my point was like in getting towards the end here, because the topics change. I also wanted to say the same thing essentially, is that like maybe we should just kind of go through a lot of these references and footnotes to supplementing documents just to kind of get like more understanding of the terms, because it feels like you're just reading it dry. And so maybe some of these like footnotes and stuff give better examples, or if you can find stuff on YouTube as well, that might be really good. I was actually even going to say, if you have time, just look up Martin Kleppmann, right? Because he wrote this book and he has a lot of YouTube talks. So it's worth it to kind of go through that as well and just kind of see like, what did he talk about? Like what things. I was thinking of adding this to our, video playlist, just kind of like some talks from his stuff, because it seems pretty interesting. So definitely check out Martin Kleppmann and understand what he's talked about over his career. This is his main book. This is the book that we're reading.
Yeah, we could do that. But I also wanted to emphasize Akansha's point, right? Like we should be comfortable moving forward into the next chapter, that we really digested the content in this chapter.
Yeah,
right.
I agree.
So if like one of us feels like we didn't understand one of the topic, then we should spend that time, go back and read that section together.
Right.
So we kind of don't skim over stuff.
I was no, I agree. And then I was just going to point out, like, he's talked about some things that I think we've mentioned as well. Like, he's talked about Abro and he's talked about Bloom filters. So maybe just even read some of these things too.
Yeah. Can you put that link in the it's like martinclipman.com? Okay.
Yeah, he's the author of the book. So, okay, I guess we'll stop here. And then, oh, one other thing I noticed is he's at Cambridge, so you might want to check out Cambridge's resources as well. But yeah, we can stop here, and then I think we'll just resume next week. And in the meantime, we can just continue like working on the notes, because I think the notes we can all kind of like
Yeah.
look at or understand a little bit better.
Yeah. So Vijay, you said you could put in some index, right, in the document. Can you do that? Index, yeah, you can kind of put links to on the top how to jump to that section.
Oh yeah, sure, I can do that. Yeah, you want me to put that at the top
Yeah.
here somewhere?
Yeah.
Okay. All right. Yeah, I can do that.
Yeah.
No problem.
And also show me how to do it. Okay.
Yeah, for sure. So I'm not doing anything like kind of like super complicated here, but if I like made, something, I would just kind of like say, okay, well, add a page. Actually, it wouldn't be a page, it would be a link. So I think it's just link to a page. Yeah, correct.
Oh,
And
okay.
then you just put it in there.
Oh, so you could write a header and kind of like, let's say you want to jump to Joshua block thing, right?
Mm-hmm.
How do you jump there?
Let me just look it up on Notion. I might have forgotten myself. Like hover over a link, and
okay.
that's right. Yeah.
Okay.
So like down here,
Yeah. Okay.
yeah, you probably like hover over it and then just get like copy link to block. Okay, yeah, and then you would just make the link at the top. So this is what you would copy, and then you can create jump links. So that's how you do it.
Yeah, I was expecting more word-like thing where it would auto-generate the index for me, but it didn't. So
Auto generate your schema.
So Vijay, can you show once more, please? Sorry.
Sure. So you just go over a portion like here, right? And then you just click on this like 6 dots, and it says copy link into block. And then like up here, you can just put the link, like, I guess, so this, this is raw. So what you should do is probably just put link to an existing page. Actually, one more time. Is there a pretty way of doing this? Let's see, link over a block, copy the link. Here, I'll put this in the chat if you want to use it. And then I think like you can just create a link towards the top here, like link to section. Then you just highlight it. And then you put in the link here. So
Yeah, got it.
Yeah, so that's basically how you'd create like your jump links. So let's see. Boom, done. All right. Yeah, so I think we're in a good spot. Just basically, we'll just use this week to catch up, given that there was already so much time, before spent on holidays and stuff like that. So I think we all kind of need to like come back from holiday mode.
yeah. See you.
So see you next Wednesday. Bye, everyone. Thank you.